Hi guys, today we're going to start learning how to factor. There are many different methods to factoring. Today we're going to focus on using the GCF. And usually when I say there's different methods, I follow it with I'm going to show them all to you and you pick the one that makes the most sense to you. However, factoring is not that way. You're going to need to know each one of these methods. This is going to come back up pretty heavily in Algebra 2. So using the GCF is the first method we're going to learn, and then we'll build some more onto that, and then sometimes you'll need to use them all together, sometimes you need to use just one. So let's take a look at the vocabulary that we need. So the first is, what is this GCF? GCF should sound familiar, greatest common factor. What's going to be different with it now as to what you did in the past you probably just looked at constants, just numbers, and found the greatest common factor between them. Now we're looking at terms that sometimes include variables and looking at polynomials, and then we can divide that out of all the polynomials. So GCF is greatest common factor. It is the largest number, variable, or both that can evenly be divided out of all the terms in a given polynomial. In order for it to be a GCF, it has to be able to be divided out of every term. And factor. So factor we use two ways. The noun, it's a number or a variable, or like I said above, both, that can be evenly divided out of a term. So a factor of something is the noun. When we are factoring, then we're using it as a verb, or saying factor the polynomial. We're using that as an action, as a verb. That is the process of undoing multiplication. So we're unmultiplying. In the last couple lessons, we multiplied polynomials. We used distributive method. Now factoring is essentially undoing the distribution. So what does this look like? Well, sometimes we can only factor out a number. Sometimes the only factor they have in common is a number. So if we look at 6x plus 9, we can decide the factors of 6. So the things that can multiply to give us 6. If I do my 6 here, I have 1 times 6, 2 times 3, and those are the only factors for 6. So let's see what we have for 9. 9, I have factors of 1 and 9, 3 and 3, and those are the only factors of 9. So we're looking for the greatest factor they have in common. So if I go through, they both have 1 in common, but all numbers are going to have 1 in common. That's not going to help us here. This has a 2, this doesn't. This has a 6, this doesn't. 3, 3. The largest number they both have in common as a factor is 3. So our GCF is 3. They do not have any variables in common. This term has an x. This does not have any variables, so they're not in common. So in this case, the GCF, the only thing we can factor out is a number, which is 3. So I write the 3. I write my parentheses, because remember, we are undistributing. So I'm going to pull that 3 out front. To do that, I do the opposite of when I distribute. When I distribute, I'm multiplying. So when I'm, undistributing, I'm dividing. So I'm going to take this term, 6x, divide it by 3. So 6 divided by 3 gives me 2x. There was nothing to change that. So 6x divided by 3 leaves me with 2x. And then I also need to divide that 3 out of the 9. 9 divided by 3 is positive 3. Close my parenthesis. This is the factored answer. If you want to double check yourself, you can always do the reverse, redistribute, and you should end up with this. So 3 times 2x gives me 6x, that's right. 3 times 3 gives me positive 9, that's right. So this is my factored answer. That is correct. Let's look at the next one. 3x squared plus 21x minus 30. So if I look at my 3, 21, and 30, the only factors I have of 3 are 1 and 3. So if I look, 21 can also be divided by 3, and 30 can be divided by 3. So my GCF just happens to be 3 in this one too. This term has an x squared. This one has an x. So far we have x's in common. However, the last term does not have an x. All of them have to have it in common for it to be a GCF. So here again, we can only take out a number. So I'm going to divide that out of all three terms and see what's left over. So 3x squared divided by 3 leaves me with x squared, because 3 divided by 3 is 1. I don't need to write that there, but you could. 21x divided by 3 gives me 7x, positive. Negative 30 divided by 3 is negative 10. And again, if I want to check my work, I can mentally redistribute, and I should end up where I started. 3 times x squared is 3x squared. 3 times 7x is 21x. 3 times negative 10 is negative 30. Checks out. That is my factored answer. So those two were an example of polynomials where you could only factor out a number. Now let's look at some examples where you can only factor out a variable. 3x squared minus 5x. So I look at my 3 and my 5 as coefficients. Well, 3, the factors are 1 and 3. 5, our factors are 1 and 5. They have 1 in common, but dividing by 1 doesn't change anything. So that's not going to be a GCF. So our coefficients don't have any factors in common. They're going to be helpful. Let's look at our variables. We have an x squared and we have an x. So both of our terms have an x, so I know that they have something in common. Now I need to decide what's the most they have in common. Well, remember, x squared means that I have x times itself twice. I have two x's. And over here, that has an exponent of 1. I just have 1x. So they each have an x in common. So my GCF is an x to the first. So I will divide that out. So if I had 3x squared and took out an x, so if I had 3xx and I took out one of the x's, I still have the 3 and I still have one of the x's. And then I have negative 5x. I took out an x. I had an x, took one out, so there's no more x. I just have the minus 5. And again, I can redistribute mentally to make sure that I did this right. X times 3x is 3x squared. That's what I had to begin with. X times negative 5 is negative 5x. So that works out. Let's look at this one. If it helps you to write your variables out, you may absolutely do that. So 3 and then y to the fourth is like I have 4y's plus 15 and 3y's minus 2 with 2y's. Remember, the exponent is telling me how many y's I have. So 3, 15, and 2, they have no factors in common other than 1, and 1 is not going to help us, so we're not going to take that out. Then I look at my y's. This one has 4, this one has 3, this one has 2, which means they each have 2. So again, you can write this out to visually see how many they have in common. The shortcut is if they all have the same variable, y, you look at the one with the smallest exponent, 2. Y to the second is what they will all have in common. So they each had 2 y's, so y to the second is my GCF. And then I need to divide that out of every term. So 3y to the fourth divided by y squared leaves me with 3. I had 4 y's. I took 2 of them out. I am left with 2. So 3y squared. 15y to the third divided by y squared gives me plus 15y. I started with 3. I took 2 out. I have 1 left. Minus 2y squared. So negative 2y squared divided by y squared. I still have the negative 2. I started with 2 y's. I took 2 of them out, so there's none left in that term. So if we mentally redistribute, y squared times 3y squared is 3y to the fourth. That works. Y squared times 15y is 15y to the third. That checks out. Y squared times negative 2 is negative 2y squared. So that one is correctly factored. So this brings me to another rule. When we were multiplying polynomials, we learned the rule that when multiplying the same bases, you add the exponents. So now when we are unmultiplying, when we are dividing, it makes sense that when we multiply, we add. So when we divide, we subtract the exponents. So when I did y to the fourth divided by y squared, 4 minus 2 gave me 2. When I did y to the third divided by y squared, 3 minus 2 gave me the exponent of 1. And then y squared divided by y squared, 2 minus 2 is y to the 0, which means we don't even put the y there. So a couple different ways to look at this and still get the correct answer. So far we talked about when our GCF was just a number, when our GCF was only a variable. So now let's look at when it's both. 8n squared plus 10n. Well, 8 has factors of 1 and 8, 2 and 4. 10 has factors of 1 and 10, 2 and 5. So the largest number they both have in common is 2. So that is part of my GCF. Now I look at the variables. This one has an n squared, this one has an n. They both have n's in common. That has 2, this only has 1. So again, that shortcut, if they both have the same letter, look at the one with the smaller exponent, which is this one, n to the first. If this only has one n, I can't take more than one n out of that. That's the most they can both have in common. So 2n is our GCF in this polynomial. So I'm going to write that out front. Remember, I am undistributing it. It needs to stay in the problem. I move it out front. And then I divide it out of each term. So 8n squared divided by 2n. Well, 8 divided by 2 is 4. N squared divided by n. So I had two n's. I took one out. That leaves me with 1, or 2 minus 1 is 1. 10 divided by 2 is positive 5. N took out an n, so there's no n left in that term. So 2n times 4n is 8n squared. That works. 2n times 5 is 10n. So we just factored a GCF that had both a number and a variable in it. Look at the next one. We have 12 and 4. So 12, we have 1 and 12, we have 2 and 6, and we have 3 times 4. And 4, we have 1 and 4, and we have 2 and 2. So notice, they both have 2 in common, but remember what the G stands for, greatest common factor. We're not looking for anything they have in common. We are looking for the biggest number they have in common. So the biggest number that both 12 and 4 have in common is 4. So that is part of our GCF. Then I look at the variables. This has a t, that also has a t. So they have t's in common. I look for the smaller exponent. That has an exponent of 3. This is 2. So t squared. So the GCF, greatest common factor of this binomial, is 4t squared. I can take that evenly out of both of those terms. So let's divide that out and see what happens. 12 divided by 4 is 3. T to the third divided by t squared. I had 3 t's. I took 2 out. 3 minus 2 gives me t to the first. And then negative 4 divided by 4 is negative 1. T squared divided by t squared. I started with 2. I took 2 out. There's no t's left. So notice, this was The same term as this, 4t squared, and we took out 4t squared. That didn't disappear. Something divided by itself equals 1. I need to have that there. Otherwise, when I redistribute, it would not get me back here. So 4t squared times 3t is 12t to the third. If I just left this blank saying, oh, they canceled, there's nothing there, that's all I would have when I redistribute. That is not the same thing. I need that negative 1 there. 4t squared times negative 1 gives me negative 4t squared. So those are our options for greatest common factor. Sometimes it's only a number, sometimes it is only a variable, sometimes it can be both. So what are other things that you might see? Well, it's possible to have a negative GCF. It's more rare. Most of the time you will have a positive. But here's how to know when you need to take out a negative GCF. It all depends on the first term of the polynomial. When the first term is negative, then you take out a negative GCF. Does not matter about any of the other terms or their signs. It only matters about the first. So negative 7t squared plus 10t, negative 7, positive 10, so 7 and 10, they don't have any factors in common. T squared, t, they both have a t in common. Smaller exponent is t to the first. So I can take out a t, but remember that first term is negative, so I'm taking out a negative t as my GCF. So then when I divide negative 7, so that's like a negative 1 in front of there. Negative 7 divided by negative 1 is positive 7. When I divide out a negative, that's going to change my sign. T squared divided by t, I had 2, took 1 out, I am left with 1t, so 7t. 10t divided by negative t, so 10 divided by negative 1 is negative 10. I started with a t, I took 1 out, no t left. So that is our factored answer. Let's take a look at another example of that. So here I have negative 3x to the fourth plus 21x squared minus 9x. I have 3, 21, and 9. The greatest common factor between those three terms is 3. My first term is negative, so I'm taking out a negative 3. Oops. Look at our variables. I have x, x, x. All of them have an x, so I know I can take that out. That has an exponent of 4, 2, and a 1, so that's the most I can take out is x to the first. So negative 3x is what I'm going to divide out at each of these terms. So negative 3x to the fourth divided by negative 3x. Well, negative 3 times negative 3 is positive 1. X to the fourth divided by x is x to the third, positive x to the third. 21 divided by negative 3 is negative 7. 2 x's, take 1 out, leaves me with an x. Negative 9 divided by negative 3 is positive 3. Had an x, took an x out, so no x is left in that term. And again, if you were to mentally redistribute, you should end up where you started. So I want to mention again, that is few and far between. If you find yourself taking out negative GCFs more than positives, then you're doing something wrong. It is only when the first term of the polynomial is negative. That is the only time you take out the negative GCF. So other things you may see. What happens when there is more than one variable? So it is possible for terms to have more than one variable in there. It is possible that more than one variable can be in your GCF. Let's take a look. A squared b c to the third minus 5a squared c. If I look at my coefficients, this just has a 1, that has a 5, so there's no number that's in common. Then I look at my variables. I have a and a, so that's in common so far. I'll come back to look at that. This has a b This term does not have a b, so I cannot take out any b's. It is not in all of the terms. This one has a c, and this one has a c, so that's in common. So I'm going to look at each of these letters individually to figure out how many I can take out. This has two a's, a squared, and this has two a's, a squared. So I can take a squared out of both of those terms. We already said we can't take a b out of both because this term, the second term, does not have a b to take out of it, so it's not in common. This has c to the third, this has c to the first, so the most I can take out is a c to the first. So my GCF is a squared c. I'm going to write that down and then divide that out. I had two a's, I took two a's out of that term, so there's no a's left in that term. B, I didn't take out any b's, so that's still there. I had three c's, took one out, so I have two left. So b squared is what's left in that first term when I divide out a squared c. -5, there was no number to change that. A squared, I took out a squared, so there's no a's left in that term. Had a c, took out a c, so there's no c's left in that term. So this is our factored answer. Look at the one below it. I look at my coefficients, I have 4, 4, and 2. Well, the GCF, I know the greatest number that can divide evenly out of all three of those is a 2. So I can take a number out here. Then I have y, y, and y. So I know that I'll be able to take a y. This had to the fourth, to the third, to the second. So 2 is the smallest exponent. So y squared I can take out. This has a z, this has a z. But look back here, our third term does not have a z. So even though the first two have the z, all the terms have to have it for it to be in common, or I can't take it out. So the only thing I can take out of this one is 2y squared. So 4 divided by 2 is 2. Y to the fourth divided by y squared. I had 4, I took 2 out, so I am left with 2 in that term. 4 divided by 2 is 2. 3 y's, take out 2, I am left with 1. And I still have this z because I didn't take any out in the GCF. I couldn't. Ooh, and I forgot that in the first term. Careful. So that z was still there. So 2y squared z is left in that first term. The second term is 2yz. And on to the third term. -2 divided by 2 is -1. 2 y's. Took out 2 y's, so no y's left. So this is our factored answer. One more thing that you have to be on the lookout for is what happens when there is no GCF. What happens when there's no number in common and there's no variable in common and there's nothing that you can take out of both. So an example, we have n squared plus 10. That has a coefficient of 1, 1, and 10. They don't have anything in common. This has an n. This term does not have an n. So again, nothing in common. So there is no GCF. They have no factors in common. Well, anytime we have something that can only be divided by 1 and itself, can't be simplified, we call prime. Or you can also say it is not factorable. So either one of those answers will be recognized. It is prime, or you can write not factorable. So this other example, we have 4x to the third minus 5y to the third. So 4 and 5, they have no numbers in common. Here we have x to the third, but there's no x in this term. Here we have a y, but there's no y in this term. So even though the exponents are the same, they do not have the same letters, so we can't take anything the same out of both of those terms. So again, no GCF, which means that this is prime or not factorable. So this week you have 2 assignments based off of this lesson. The first one is factoring polynomials by the GCF. It's a Google form, has 12 multiple choice questions. Again, like last week or 2 weeks ago, I guess that was, you can resubmit. I can see how many times you've submitted it. So if you are not happy with your score after, I'd say 2 times, then please check in with me. Let's get some help so that you have an idea what you're doing for the next time. And then the other one I'm going to show you now. The other assignment is a GCF make a match. That is on Google Slides. Both of these are posted in Google Classroom. And I put a picture here to show you what that looks like. Again, your weekly overview that I have every week has that document linked to my office hours, has the times of my office hours all week, first assignment, second assignment. So let's look at that second assignment. When you click into that second assignment, it's going to look like this, take you to Google Slides. So I left this direction slide in here that reminds you, you must be in edit mode. If you go to presentation mode, it's not going to let you complete this. So stay in this mode, which is edit mode. These are the 2 slides that you need to complete. So problem numbers 1 through 6 are on the first slide, and then 7 through 12 on the second slide. What I wanted to show you here is there is a way, there's a couple different ways to make this a little bit bigger if that's small on your screen. The one I'm going to show you is what I think is going to be the best. If you go up to View, Full Screen, that is different than Present. You do not want to go to Present mode. You won't be able to do it. You'll have to get back out of it. So if you go to Full Screen, now it makes that a little bigger. It tells you how to get out of full screen. So it says the controls are hidden. That little ribbon at the top went away. It says press escape in order to get out of this. So that's how eventually you'll be able to get back to that other screen. So now this made this a little bigger. What this is on the right, you have these different boxes that you can drag and drop with the problems on the left. So for each problem, let's take a look at number 1. You have to find the GCF. So 3y squared plus 15. 3 and 15. I know the number they have in common, the factor they have in common, the greatest factor is 3. So let's look. Here has y squared. This does not have a y, so they don't have a variable in common. In this one, the GCF is just 3. So I want to find that. Get my arrows. Click and hold while I drag and put that in the spot for the GCF out front. Then I divide that out and see what's left in my answer. Well, 3y squared divided by 3 leaves me with y squared, and 15 divided by 3 leaves me with plus 5. So I'm looking for y squared plus 5. That's right here. Click, hold the button in, and use a mouse pad to drag it over. So my first problem is finished. That's how you will approach the rest of these. When you are finished, make sure that you go back into Google Classroom and click to submit it so that I know that it's ready to grade. If you get less than 12 out of 12, so less than 100%, I will give you feedback. As long as it's before the due date, you can try to make fixes on the problems that I tell you and resubmit it for a higher grade. As always, if you need me, feel free to email or stop in during my office hours. Good luck, guys.